Okay, so now because it's a regular polygon, what is figure one actually called? Yeah, equilateral triangle. All right, a regular triangle. All right, it just means it's equilateral. Now in the book, all right, there's a formula for area of a regular polygon. Its area equals 1/2 perimeter times the apothem. All right, never ever used apothem before except in this formula. So I don't use that formula. All right, I can explain the formula, but it's completely unnecessary. The reason why I say it's completely unnecessary is because every polygon can be broken down into what? Into triangles. That is correct. All right. So when we do that, what I want to show you is just quickly look at number 2. You don't have to, you can just pay attention. It might be easier, but here you can understand what I'm saying. Right. So how many triangles are there? 5, right? So I would argue, or I would rather teach you that the area of that pentagon is just what?
1/2 base times 5.
Yes. So listen to what he just said. Very nice. 1/2 base times height times 5. So big agree with that? Now, can someone please tell me what 5 times the base represents? What does 5? That's exactly correct. So the perimeter base times 5 gives you the perimeter. So now you can just say the area is 1/2 perimeter times the height. Right. So I don't know why they just don't say 1/2 perimeter times height, but this right here is called the apothem. Do I really care? No, because I call it what? The height of the triangle. All right. So it doesn't really make any sense to me. All right. I would always look at a regular polygon as the area of a triangle times the number of sides. All right. That's how I want you to look at it. All right. Now, again, why is it super easy? It's super easy because we know trig and we can calculate the area of any triangle now. Really simple. Really, really simple. I like it because it's helping us review trig. It's helping us review 30, 60, 90 triangles. But also, I want to now refer back to number 1. Do I really need 1/2 perimeter times the apothem here? No, that would be silly, right? So they're telling you that this is 14, correct? And this is 14, correct? So this distance from here to here, somebody tell me, is how much? 7. And so what is this length right here? 7 radical 3, correct. Because don't forget, this creates a 30, 60, 90 triangle. Is everybody with me on that? Now, the height, so that's one way to look at it, but I don't even look at it like that. I just draw this height down. Hold on one second. I'm just drawing this height down. Oh, yeah. So 30, from the 30 to the 60. That's a 30. That's a 60. Oh, yeah. I was looking at it as a 30. Thank you very much, guys. Thanks for working with me. All right. Good job, guys. Sorry about that. You are 100% correct. This is, I was thinking it was the 30 side. That is the what? That's the 60. So go from the 60 to the 30, we divide by radical 3. So this is 7 divided by radical 3. But when you rationalize, it becomes 7 radical 3 over 3. Now, I want you to say, okay, I just forgot my radical rule. So how did you get 7 radical 3 over 3? Somebody need any help with 7 radical 3 over 3? Anybody have any question with 7 radical 3 over 3? All right, that's probably another reason why I don't do it that way, because I'll make a silly mistake like that. So what I really want to do is pull this off to the side so we can see something. Does everybody agree? This right here is 14, right? This right here is what? The actual height of the triangle is what? Yeah, that is actually 7 radical 3. All right, this is actually 7 radical 3. Is everybody okay with that? And so now the area is just what? 1/2 times 14 times 7 radical 3. Right? I just don't use the formula for those of you guys who like periodically look at the formulas in the book. All right, I just don't use that. So everybody knows the area is going to be what? 49 radical 3 meters squared. All right. Anybody have any questions with that? All right, super easy. All right, now let's move forward to this pentagon. All right. So now is this length right here 5, or I'm sorry, 10? Is that 10? In other words, is this an equilateral triangle?
Yeah.
Somebody else
No,
want
it's
to?
not.
Definitely not. Right, why is that? Because look here, guys. Again, this will be very easy. What's this angle measure right here? 72. Thank you very much. Very good. 72 degrees. How did you get that?
5 triangles.
Yeah, 5 triangles. 360 divided by 5. That angle is 72. So now we know it's not what? It's not equilateral because equilateral is 60, correct? All right, now please let me just review this with you. It's super easy. For those of you guys who didn't like the trig chapter and you kind of did average or whatever, it wasn't your favorites. All right, this is more applications of the trig. All right, it's really simple. All right, if you forgot or you didn't learn it, now's the second time. All right, you get to learn it. All right, so now someone please tell me what this angle is right here. 36, right? So I know this is 36. Now I'm going to white this out for a second because I don't like that. All right, now I want someone to tell me what this distance is from here to here. 5, right? And if you want to put 5 over here, that's fine. All right, now off to the side, notice what I did. I'm erasing this, their dumb formula. All right, what is the base of our triangle? 10. Do we know the height? No, we're calculating the height, right? So this right here, all right, somebody who remembers what trig function is involved? Tangent. Does anybody agree with that? Everybody's good? So it would be what? Tangent. Tangent of what? 36 equals 5 over h. I like to use h because that's the height. All right, now who doesn't know that? If you forgot, it's okay. Tangents opposite over adjacent, correct? So now I'm expecting everybody to look at this and just put it in your calculator, right? You don't have to cross multiply. You should be able to visually say, what am I doing to the h? Multiplying the h, and then what? Dividing by tangent. All right, that's what you should be able to visually tell me. So now I know h is, someone's helping me, approximately 6.882. Now we put that number in here. All right, so you can say 6.882 times 5 times 10 divided by 2. And so my area is equal to
172.048.
Yes. And then I erased the units. What's the units? Inches squared. All right. Is everybody good with that? Anybody have any questions? Remember what I try to tell you, don't let someone else do the work. You got a calculator, pull out the calculator, do the work. Don't just say that's the answer and go with them. Do the work yourself, then you know whether or not you understand what we're doing. Now, if you have no other questions, we're just going to move right on to number 3 and show you how silly this is. This is a what? Square. Why would I do 1/2 perimeter times the apothem. That would be silly, right? Absolutely silly, right? The area is what?
175,
How do we get 175?
15 squared.
Well, 15 squared today is, don't worry. I made a mistake today, so I'm letting you off the hook. All right, 225 square inches. All right, I don't understand. All right, so there you have it. Anybody have any questions? All right, so now we're moving on to question number 4. Now, with question number 4, this is a what?
60, 30, 90.
It's a 30, 60, 90. It is a hexagon, right? 6 sides. Hexagon is unique because it divides it into equilateral triangles. All right, it divides it into equilateral triangles. So once again, I would like everybody to say area equals 1/2 base times height, this time times what? Times 6. Exactly. So now I can say area equals 1/2. I don't know what the base is, but I know what the height is. The height is what? 5 radical 3 times 6. And now because we have done this thousands of times, everybody should be able to say, now we're going to do it correctly this time. So this is the 30, this is the 60. If this is 5 radical 3, then what's this length? 5. Thank you. So the base of the triangle is what? 10. All right. Now, again, we're leaving it as radical 3. All right. So my area is equal to what? 150 radical 3 centimeters squared. So on the triangle and the square and the pentagon, you can leave it exact answers. Everything else is going to have an approximation. Anybody have any issues with that? Nobody? All right, I told you, simple. All right, here we go. So this is a what type of shape? Adagon. Good. We'll call it an adagon. All right. At least you didn't call it a stop sign. Okay. But that is definitely an adagon. Okay. So again, everybody's just going to put this down. Area equals 1/2 base times height times what? 8. Area equals 1/2. What's the base? 10. What's our height? We don't know. And this is 8. Now, because it's an octagon, we have to use what? We have to use trig. All right, so I want everyone now, don't look at your neighbor for the answer. I need someone to tell me what this angle is right there. Thank you very much. Very nice. Those of you guys who are with me. 22.5 degrees. That 22.5 degrees. All right, now you can see why I don't like this right there. So what's this length from here to here, guys? 5. Thank you very much. And it is 5 inches. So now I need to calculate the height. So everybody's going to write down the relationship, the height. And someone tell me. I don't want the answer. I want you to tell me the relationship. Go. Tangent of what? 22.5 is equal to 5 over h. All right. And we don't have to do that work anymore. Everybody can do the mental math on that and just tell me h is approximately what? 0.071. That number goes in here, please. And now we know the area of that adagon is what? Somebody said loud and proud. And then that would be square inches. Anybody else agree? All right. Now you know it's not hard. I told you, simple, simple, simple. Okay, now this one's kind of silly because they gave us all the information. Does everybody agree? Number 6. So that's real nice. So everybody's going to put area equals 1/2. What's the base? 10.9. What's the height? And how many are there? 5. All right. So that equals, I'm waiting. 204 point what? 375 meters squared. Anybody have any issues? I'm agreeing. That was way too easy. I meant to white one of those out, actually. All right, here we go. Let's go down here. All right, now we're just getting into just composite figures where they're made up of just multiple shapes. All right, so let's take a look here. All right, now I want the exact answers. You know, I don't like this garbage where you round, okay? So I want everybody, this is what I want on your paper. Area, what 2 shapes do we have? Semicircle and a rectangle. So I want everybody to write down LW plus what is the other formula?
Pi squared divided by 2.
Pi r squared divided by 2. But me personally, I like 1/2 pi r squared. I want everybody to write the formula for the area, because on some standardized tests, you might be going to a private school. They're not going to give you formulas. All right. So you have to know the formulas. Anybody have any questions? Write the formula and then make the substitutions. All right. So area is equal to, I don't care if you tell me what 34 times 15 is. Plus, now leave this 1/2 pi. What's the radius? 7.5. All right. So we're going to say area is equal to 510 plus 88.25. I'm not saying that's correct. Pi square feet. Is that correct? Anybody else get 88.25? Everybody? Anybody have any issues? All right, let's move on. Let's see what, oh. So what about number 8? What's the area of a parallelogram?
Base.
Yeah, base times height. How many are there? 2. All right. So it looks a little weird, but what definitely is the answer? Everybody look at that and tell me the answer is obviously.
960.
Yeah, because you can just do what?
24.
You can do what? And then multiply that by what? 2. Or you can just do, right, 40 times 24. Now, believe it or not, I know it sounds weird. That's hard for my eyes to see. Like, I don't see that as obviously 40 times 24, right? But if you draw from here to here, does everybody see that's the height? Right? If I extend that out, that is the height. Does everybody agree? And then that has to be the same height as this, correct? All right, so maybe you understand what I'm saying. So that was 960, and then we say square inches. Is everybody okay with that? Number 8. Area of a parallelogram is just base times height. All right, let's check out this guy over here. Are those the same triangles? Definitely not. Yeah, I just don't see a big deal here. All right, everybody just use your calculator to calculate that. All right, that one's really easy. Area equals, and then you should be able to type it straight in on the calculator. Everybody's typing it on the calculator. Let's go, chop, chop. Come up with an answer.
466.
Somebody said 466. I'm not sure if we agree. 466, 466. Everybody's okay with that? Now, again, if you want to write 1/2 base times height plus 1/2 base times height, that's perfectly fine with me. But we know the base and the height, base and the height, that's just straightforward. I could give that to my sixth graders and they can do that. Okay, so now number 10. What do we have here?
Triangle and square.
Triangle and a square. So everybody calculate that area. This is kind of embarrassing. All right, it's easy. Some 704 centimeters squared. Now you have to be careful because what's the height of the triangle?
20.
Does everybody agree with that? The height of the triangle is 20. So again, guys, I don't care about being wrong, right? Just verify that you know how to do it. So you can say it's easy. Anybody have any issues with that being 704 centimeters squared? Anybody? Anybody? Okay. Ooh, who remembers the formula for area of a trapezoid?
Isn't it like 1/2? So it's B1 plus like B.
1/2 parentheses B1 plus B2 parentheses F.
Yeah, so I always just tell kids it's just, no, you're right. It's the average of the bases. Average of the bases times the height. Average of the bases times the height. All right, now, are these identical trapezoids? Yes. All right, so really, do I have to do the 1/2? No, because you're going to end up multiplying by what? 2. So what is the sum of the two bases? Times what? Times 64.
Wait,
I don't think that's right, is it?
no, it's not.
Or shouldn't it be 30 times?
Yeah.
Well, there's two.
No, there's two, yeah, but.
Okay, yeah, but you
the
have to
height
find the
is
two,
times
you have
the
to add
height.
those and divide by 2.
Yes, that's correct. So look what you're doing. So just to make sure, and that's what I'm saying, you guys got to see it now. So to me personally, I did 1/2 base 1 plus base 2 times the height times 2. Does everybody see that? Everybody's agreeing? Now, what is the height of one of the trapezoids? 32, right? Does everybody agree with that? Because we're multiplying by 2, we're only using this height right here, which is 32. And then we're going to multiply that by, well, what was I saying about this right here?
You have to divide by 2. 'cause you have
Yes, you don't need to divide by 2 because you're multiplying by 2, but then you have to know the base 1 plus base 2 is what? 60. So it was 60 times 32, not 60 times 64. So those of you guys who are good at visualizing things, that's really good. All right, those of you that are like me, I just go ahead and make sure I'm right, write it out. All right, then I think you're going to be right. So what's 60 times 32? 1,920 meters squared. Everybody's good with that? All right, let's see if there's something else. Okay, practice number 12 for homework. The rest of these kind of can be. All right, let's take a look. Let's just jump down. These down here at the bottom are kind of like SAT questions. So we got time. I'll work these with you. All right, but I want everybody to be able to look at that and tell me what the answer is to 19. Everybody should just be able to visualize what that is. Tell us. 64. You are amazing. That is correct. 64 minus 8 pi inches squared. Very good visualizing. All right, now don't be confused. Anybody have any questions with how we got 8 pi?
Yeah.
Because we're cutting out a what? Semicircle. So what's the radius of the circle? Squared.
16.
divided by 2.
Oh, okay.
There we have it. All right, very nice. 64 minus 8 pi. All right, let's knock out 20 real quick. So in my opinion, we should just go area equals, what's the formula?
Length times width times squared.
I like it. Length times width plus pi r squared. So I'm waiting. Exact answers.
450 plus 56.25 pi.
Anybody else get that? Come on now, don't take her word for it. Anybody? Good, thank you. Everybody's good with that? Any questions? Aiden, how you doing? Okay, so let's take a quick look at 21. Yeah, we can find the exact area here. So I need some help here with this. What's this length from here to here? 22. So what's the length from here to here? Wow. Thank you. And then what's this right here? 22. All right, so what is this length right here, guys? Is that right? Is everybody agreeing? Come on. 11 radical 3. Everybody's good? So I have equilateral triangle, a right triangle, and a square. All right, so I want the exact area of the triangle and the sum of the square in the triangle. So area equals. Because this is 22, right? So this would be 11, right? Come on, guys, I need some help.
I got 660 plus 242 back to 33 square.
Say it again.
660 plus 242 back.
I got that.
I don't think so.
That's what I got.
How did you get 242?
42 times the last.
It's 120.
Yeah.
Did you do the times now?
Yeah, I forgot. I thought. Oh, wait.
What is it?
120.
Yeah, that's what I'm thinking. I'm thinking this should have been 121. Does everybody agree with that? 121 radical 3. No, I didn't do the area of the others. Somebody else get 660? Yeah, I just don't think that's that hard. Oh, 24 is kind of interesting one. I've seen that on the SAT. Everybody, please just look at that and tell me what the answer is. 400. Yeah. Can't tell you how many high school kids missed that. How's that 400?
It's a rectangle.
Better than that.
It's a square.
Square. Square with a circle what? Or semicircle? Cut out,
But you added some.
but you added it back in. Right? So here we go. Let's look at this right here. What'd you say?
The square oddly shaped.
Square oddly shaped.
Like,
I think you like.
The world according to Aiden. So this is this. right? So just 400. Easy, easy, easy. Like I said, I can't tell how many people miss that. Okay, and then you're looking down here. Be careful with this guy over here. I like to draw this straight across. So we have a what and a what here? Trapezoid and a semicircle. Trapezoid and a semicircle. So I want the exact area of the semicircle plus the area of the trapezoid. Over here, 22, we have a what? Square. Yeah, guys, I don't think it's that bad. I don't care. All right, here we go. Finish up everything. All right, especially these guys right here, 16, 14. I mean, everybody can do 13. We've done that a million times. All right, but practice using your trig. Practice using your trig for the hexagon and for the equilateral triangle. Those are exact areas. Anybody have any questions with that? Anybody have any questions? All right, guys, we still have a whole 12 minutes, so you should be able to get it done. Quick, quick, quick.